Before one small step for man and one giant leap for mankind, a team of daring space pioneers embarked on a pair of experimental rocket projects to study the Earth and the heavens. With eyes on the sky and the future of space exploration, flight controllers inside NASA's Mercury Control Center watched America's space program take flight. And so here, the story of American space exploration began.
In the late 1950s, the earliest chapters of American space exploration were written along Florida's central Atlantic coast. Later known as the Mission Control Center, NASA's Mercury Control Center was the United States' first mission control for both unmanned and manned space programs. The Mercury Control Center controlled the flights of 3 different vehicles from 3 different seaside launch pads at the Cape. The MCC housed the program's critical launch equipment. Inside the unassuming 30,000 square foot building known to NASA as Building 1385, flight controllers monitored and controlled the Project Mercury launches and the first 3 flights of the Gemini program. The Mercury Gemini program set the stage for the highly technical challenges and accomplishments later executed by NASA Kennedy Space Center.
The Mercury program was absolutely essential to all of our space programs that followed, and the main reason being it was the proof of the pudding that we could launch into space, we could put a man in there, we could preserve him throughout our mission, we could bring him back safely, and from there Mercury led into Gemini, going into the Apollo program where we went to the moon.
Florida's mild climate, vast undeveloped land surrounding the Cape, and its proximity to water made it a good choice for launching rockets. And so the Mercury Control Center was designed by the Army Corps of Engineers and built in stages on Cape Canaveral Air Force Station between 1956 and 1963. The modest-looking building faced east toward the ocean, though thick vegetation hid it from view. The MCC had an inset floor and a flat roof. The exterior was designed with a pair of light metal swing doors that open onto covered entrances. Later, the famous NASA logo graced a west-facing exterior wall. Floodlights and speakers were placed along the upper roof edge. Project Mercury began in 1958, 1 week after NASA was enacted, and 3 days before the 1-year anniversary of the Soviets' launch of Sputnik.
To steal from Dickens, it was the best of times and the worst of times for the space program. Because, of course, the Russians had put up the first satellite. We had put up a satellite on January 31st of 1958, and the space race was on. Before that time, the missile race was on, and the Soviet Union was rattling their rockets at the United States, and it was a very, very tough time for our nation. So now we were in a space race at the same time, and it appeared once again we were behind.
I would have to say nothing was more exciting than working on the Mercury program because we were doing things for the first time. It was new.
The project's goals were straightforward: orbit a manned spacecraft around Earth, investigate the pilot's ability to function in space, and to recover both the pilot and the spacecraft safely. A flight control room was added to the existing building beginning in 1959 for the upcoming Mercury flights. The upgrade included a viewing area that was built by Bell Telephone Incorporated. A second addition, along the west elevation, provided additional space for support equipment. The flight control room occupied just 10% of the entire building. Christopher Kraft would be the very first flight director, and he was key in the development of the flight control operations and the first flight control team. Chris gave final launch approval. His console was equipped with a black and white monitor, and he had access to every communication circuit, called loops.
But in the final analysis, it had to be this gentleman right here, Chris Kraft, as flight director, running the entire show, and that's what made it work. Chris was an amazing person. He's the only I'm a communicator, and he's the only person I ever saw that could listen and understand 8 intercom nets simultaneously. I've always teased him about that, but that's just he's the only person I know that could do that.
So the combination of the two, between the guys on the ground and the crew in space, really was a phenomenal thing in its time. I think we were able to get a lot done, more done than had we not had a control center.
We had the Mercury Control Center right there, right adjacent to the press site, actually. And Chris Kraft was the flight director. Walt Williams was the operations director. And you had a number of other key people who grew up in that program and carried us all the way to the moon as far as flight control was concerned. They had a fantastic worldwide map in there because they wanted to cover the orbital flights that would follow on the Mercury Atlas.
The MCC was part of the Spaceflight Tracking and Data Network. The tracking network provided communication between the capsule and mission control with an impressive system of ships on 3 oceans and 18 ground stations on 3 continents. As part of this worldwide network of tracking stations, a 2-dimensional world map and 2 large projector boards dominated the front wall of the flight control room. The map used a series of circles to pinpoint tracking stations. To keep continuous track of the Mercury spacecraft, a mini-spacecraft model suspended by wires traced its orbit. The projector boards were used to display flight measurements plotted by sliding beads. Trend charts displayed the astronauts' condition. Goddard Space Flight Center in Greenbelt, Maryland, was the link between the remote tracking stations and the MCC. As Project Mercury took shape, so too did the first astronaut corps. Leroy Gordon Cooper, Virgil Gus Grissom, Alan Shepard, Walter Wally Schirra, Donald Deke Slayton, Scott Carpenter, and John Glenn became known as the Mercury 7. They were in training as teams prepared for the upcoming flights. Inaugural operations inside the MCC supported the first Mercury Redstone launch attempt. The MR-1 launch on November 21, 1960 from Launch Pad 6 was classified unsuccessful, but proved many of the systems designed for the vehicle and capsule worked. MR-1A successfully launched a few weeks later on December 19, 1960. The same spacecraft was used. About 6 months later, astronaut Alan Shepard made history with his suborbital ballistic flight on May 5, 1961.
So this was a very significant flight because the country needed this. The whole free world needed this flight at this time.
A Mercury Redstone rocket, MR-3, known as Freedom 7, lifted off from Launch Complex 5-6 at 9:34 a.m. Eastern Time. It's the first manned flight controlled by teams inside the MCC, and it lasted 15 minutes.
It was a beautiful, beautiful May morning. And I was in charge also of the telephone, the intercom service for the control center. And I was also in charge of the air-to-ground. So I had a fairly busy time during all of the launches. But obviously there was an air of excitement in the control center on that first manned flight that you couldn't duplicate anywhere in the world.
That very first flight on that Mercury Redstone, I mean, going up into space and coming back down, even though you didn't orbit the Earth, that set the stage for everything else that we've done.
As the command center, the MCC had 8 primary functions: to direct all aspects of the capsule's flight, monitor the health of the astronaut and the system status of the capsule, make decisions to abort a mission, determine the proper procedures following an abort procedure, command the re-entry of the capsule, keep the astronauts and all the tracking stations informed of the mission's progress, coordinate and maintain the flow of communication between all tracking stations, and inform the recovery forces when the capsule would re-enter the atmosphere. It would take 14 flight controllers to meet these mission objectives. The first critical row of flight control seats was coined the trench. One of those important positions was the capsule communicator, or CAPCOM position, one held only by an astronaut.
I think the Capcom today is very much the same as it was back during the early Mercury days. It's that point of contact with the crew. It provides the crew perspective to the control team. Yeah, very similar.
Public interest in the space program and the astronauts grew as Project Mercury realized much success.
Because the beaches were loaded, the program was pretty small. It was only about 350, 400 people, and it was real excitement. The cities around here were growing. The center was really on its way.
News of the Mercury missions was in the newspapers and on TV.
I've had the pleasure of covering every launch of American astronauts from Cape Canaveral, Florida.
Shorty Powers was the first public information officer for NASA. He was the voice of mission control.
We had a red light that would come on our desk, and that red light was a signal that Mercury Control would have a report in 30 seconds.
Some employees at the Cape were just as excited about the astronauts and the missions as the public.
I met all of the original 7 astronauts because they would come into the ready room. Well, they were excited like everyone else, and everything was new to them. And they would all come through because each one was interested, of course. It wouldn't just one come through, they all would come through.
The Mercury Atlas and Mercury Redstone vehicles flew 26 missions as part of Project Mercury. 6 of those were manned flights. The first orbital flight for the Mercury program was MA6.
Roger, backup clock is started.
Astronaut John Glenn performed it on February 20th, 1962. Astronaut Scott Carpenter followed Glenn's successful mission with his own orbit of the Earth later that year.
Climbing into that spacecraft and sitting on the top of the rocket was something we had simulated time and time again. So, in a certain sense, it was just another day at the office, except this time you realized that it was for real.
MA9 was the last flight of Project Mercury, piloted by Gordon Cooper on May 15, 1963, in his spacecraft named Faith 7. He was the last American to orbit the Earth solo. The mission lasted 1 day, 10 hours, 19 minutes, and 49 seconds.
I named my spacecraft Faith 7 for 3 reasons. 1, because of a belief in God and country. 2, because of a loyalty to organization, to the 2 organizations actually, which I belong. And 3, because of a confidence in the entire space team.
The Mercury program was ending, and America's second human spaceflight program was soon to begin in support of one very clear mission.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Bridging the gap between Mercury and Apollo was the Gemini program. Following the Mercury program, Gemini subjected astronauts to long-duration flights in support of the upcoming Apollo moon missions. Gemini accomplished 10 manned missions and 2 unmanned, each on a Titan II launch vehicle from Launch Complex 19. 2 astronauts flew in the capsule, which is how it got its moniker, Gemini, or Twin. Renovations to the MCC were completed in 1962 and in 1963 in support of the Gemini missions. An addition wrapped around the east, north, and most of the west and south sides of the MCC. New areas included space for flight control briefings, data analysis, and room for a new Gemini spacecraft trainer. The old trend charts on either side of the world map were replaced by rear projection screens. The world map displayed new tracking stations, and one clock above the map changed to estimated liftoff time. A desk for a public affairs officer was also added, along with a pair of consoles on the left side of the room facing inward for the support control coordinator and the display coordinator. After the conclusion of Gus Grissom and John Young's flight of Gemini 3 in March 1965, NASA transferred mission control to Houston, Texas, where it still resides today. After mission control functions were relocated to Houston, Texas, the Mercury Control Center provided backup for the initial launch and the trajectory for the remaining Gemini missions. In 1967, the MCC became a tour stop for guests visiting NASA's Kennedy Space Center Visitor Complex. A bus tour provided the public an opportunity to look through the glass windows of the viewing room and see where the first chapters of American space history were written. It was a popular attraction from 1967 through 1995. In the late 90s, the building began to show signs of aging. In an effort to preserve what remained inside the deteriorating structure, NASA removed the artifacts inside. Later, a plan was developed to create an authentic MCC flight control room exhibit at the KSC Visitor Complex.
The opportunity for relocating this amazing room full of history was to offer it to many, many more people. Accessibility to the actual facility was becoming more and more challenging, and it allowed for the consoles throughout the room to be displayed and preserved. Had they been left in the building all those years, they would be in terrible condition right now.
The exhibit is inside an 8,500 square foot building dedicated to early space exploration.
One piece at a time, we carefully removed it, brought it over. So what you see here is a duplication of the actual MCC, the Mission Control Center, with the screens, the consoles, the flooring, the finishes, and of course the tracking board. The consoles themselves, though, are completely authentic. The tracking map is completely authentic.
Guests get a memorable and authentic experience.
I think it's an amazing opportunity for our guests to look through the glass and step back in time and honor the heroic first years of our space program.
The MCC was designated by the National Park Service as a contributing structure to a National Historic Landmark District in 1984. The district consists of 7 other contributing properties: Launch Complexes 5, 6, 13, 14, 19, 26, and 34. NASA determined the Mercury Control Center was no longer needed for NASA missions and had deteriorated beyond repair. Final artifact preservation efforts began in 2009. The Mercury Control Center controlled the flights of 3 vehicles from 3 launch pads during its years of service. In March 2010, heavy equipment operated by NASA contractors leveled the concrete block and metal building.
You know, it's a transition, but we have to be energy efficient. We have to prepare for the future. We've got to prepare for going beyond low Earth orbit and doing bigger and better things. And this is all part of the process as we grow and change here at the Kennedy Space Center. We will never forget our heritage. It's crucial to us. History is important.